Up until now, we have studied about local minimum and maximum points, about absolute extremum points. Also, we have studied how to use the second derivative in order to find the concavity of functions, and also how to find local minimum and maximum points. So today we're going to solve some problems. Also in the next following videos we're going to solve some optimization problems using the knowledge that we have gained about extremum points, and also about the use of the first and second derivative. So here we are given that x plus y is equal to 9, and we have to find the values of x and y for which x squared times y will have the maximum value. Okay, so let's jump right into it. So here I think that we can write y as 9 minus x, then replace it in here in order to get the function only in the variable x. So we'll get x squared times 9 minus x will be equal to 9x squared minus x to the third power. Okay, so we can say that this is our function. F of x is equal to 9x squared minus x to the third. Okay, so we need to find the maximum value of this function, and we're going to use the second derivative test. So first of all, let's find the critical points. So f prime of x, the first derivative, will be equal to let's see, 18x minus 3x squared. And since this is a continuous function, it can only take values of that are for which f prime of x will get 0. So this function cannot be undefined. So where does f prime of x equal to 0? Well, let's factorize it. 6 minus x. So when x is equal to 0 and x is equal to 6, we will get that f prime of x is equal to 0. Okay, so these are the critical points, since the first derivative is equal to 0 when either x is equal to 0 or when x is equal to 6. Now let's find the maximum point. So we're going to use the second derivative for that, and in order to find the maximum point, f of x needs to be smaller than 0. Remember that we have studied this in the second derivative test video. Okay, so first of all, let's find the second derivative. So if you find the derivative of the first derivative, which is this one, it will be equal to 18 minus 6x. Okay, so basically 18 minus 6x has to be smaller than 0, or x has to be bigger than 3. Okay, so we have the critical points here. X is equal to 0 and x is equal to 6. Okay, so since only these 2 points are the critical points, we can clearly see that only x will satisfy this inequality. Since if we replace for 0 here in the second derivative, 18 minus 6 times 0 will get 18, which is bigger than 0. So we're looking for the value of the second derivative that is negative. So we can say that x is equal to 6, and we can check, since the second derivative was, let's see, 18 minus 6x. If you replace 6, f prime prime of 6 will be equal to minus 18, which is smaller than 0. So when x is equal to 6, we have our maximum value of the function. Now what about the y value? Well, remember that x plus y is equal to 9. These are one of the requirements that we got at the start of the problem. So y is going to be equal to 3. And we have solved our problem. In the next following videos, we're going to solve some more optimization problems, so stay tuned.